Hello, what's up guys? Welcome to new video. This video will discuss about Verilog code and Testbench in Quartus Prime. Before going to the Quartus Prime software, some knowledge needs to be known. Verilog define a circuit in the form of module. The module has a name which can be any valid identifier, followed by list of ports. The module will be end with the end module. In between, there will some other language fundamentals need to be know and need to be declare. Input, output, wire, reg, parameter, continuous statement, sequential statement, initial block, always block, module instantiation. Next go to the declarations. Port declarations. Port direction, port size, port name, port name. Port direction is input or output. Port name is legal identifier. Port size is a range from MSB to LSB. Wire list. Connect an output of one logic element in a circuit to an input to another logic element. Reg list. Used to model either combinational or sequential parts of a circuit. Parameter. Used to associates an identifier with its constant. Parameter, MSB to LSB, identifier equals, size, radix, constant. Where size is the number of bit in the constant, and radix is the number base. Supported radices are D equals decimal, B equals binary, H equals hexadecimal, O equals octal. When the command too long, we can write comments in the back of the coding. Comments. Single line comments. Use /line //. Multiple line comments. Begin with /* and end with */. Everything in between is commented out. In the Verilog coding, there are two blocks been used which are always and initial block. The initial and always construct have the same form, but statements inside initial executed only once, at the start of simulation. When multiple statement included in initial or always block, the statement begin and end are used. In Verilog code, the event control also very important. The @ symbol is used to specify an event control. Statements can be executed on changes in signal value or at a positive or negative transition of the signal value. The keyword posEdge is used for a positive transition and negedge for negative transition. At clock, Q equals D, which Q equals D is executed whenever signal clock changes value. At posEdge clock, Q equals D, which Q equals D is executed whenever signal clock does a positive transition, 0 to 1. At negedge clock, Q equals D, which Q equals D is executed whenever signal clock does a negative transition, 1 to 0. There are three different modeling styles used for the Verilog code, which are data flow modeling, behavioral modeling, and structural modeling. Data flow modeling. This type of modeling is described using continuous assignment statements. Data flow modeling utilizes Boolean equations and uses operators to push inputs and produce outputs. For example, a two-input AND gate, with output Z and inputs X and Y, is denoted as assign Z equals X * Y. Behavioral modeling. Behavioral modeling describes the behavior of a logic circuit using logic expressions. The expected behavior of a design is described in algorithmic manner or functional term using sequential or procedural assignment statement. For an example, consider the Boolean equation of the IN function, Z equals Y multiply with X. This IN function can be described by the algorithm. If all of its inputs is 1, the output is 1, otherwise output is 0. Structural modeling. Structural modeling describes the structure of the circuit in terms of circuit elements, such as logic gates. A gate is represented by indicating its functional name, output, and inputs. For example, a two-input AND gate, with output Z and inputs X and Y, is denoted as IN Z, X, Y. There are two types of assignment in the Verilog, which are continuous assignment and sequential assignment. Continuous assignment. Whenever any signal on the right-hand side changes its state, the value of the left-hand side will be re-evaluated. Begins with the assign keyword. Sequential assignment. also called as procedural assignment statement. Always block been used. An always block can contain a single statement or it can contain multiple statements. After we write a Verilog code, we need a Verilog testbench to verify that the Verilog code is correct or wrong. If wrong, the Verilog code need to change so that it come out a result that we expected. First, set timescale time unit base / time precision. This timescale will be explained in detail later. Set the module name for the testbench. In Testbench, the inputs declare as reg, while output declare as wire. Initiate the DUT, which is device under test. In between initial block, there are some standard system tasks can be used to print result. This example of Testbench show the monitor which continuously monitors listed signals. Other standard system tasks will be introduced later. The example show the command monitor the time, input and output. The input and output set as the B, which is binary number. It also can be hexadecimal number, decimal number, or octal number. In the other initial block, the delay time and the input value also been defined. In this two initial block use the begin and end. Time scale. Timescale time unit base / time precision. For time unit base used to set the time unit for one time step. For time precision base used to set the precision. For an example, timescale 1 ns / 100 ps time unit is 1 ns and round to the nearest 0.1 ns. Standard system tasks. There are 6 common standard system tasks been used in the testbench, which are monitor, display, time, stime, stop, finish. $monitor is continuously monitors listed signals. $display is prints message to the screen. $time is function that returns the current simulation time. $stime is function that returns the current simulation time. $stop is halts execution but does not exit. $finish is halts execution and exits the simulation. Okay, that's all for this video. Stay tuned to next video.